Channel 4 News. Tonight we have a special guest, Dr. Emily Youthy. She's a chemist from University of Iowa and is here to teach you about states of matter. Please give her a warm welcome.
Hi, thank you so much for having me. It is an honor.
First, can you please explain to us the three states of matter and how they differ?
Yes, of course. Solids have definite shape, volume, and melting point. They also have high density, low compressibility, and low diffusion. Liquids, however, have a definite shape but not volume. They take the shape of the container that they are in. They are more dense than gases. They have low compressibility, good diffusion, surface tension, and capillary action. And finally, gases. They have no shape, no definite volume. They flow, and they also have low density. They can be compressed and they diffuse into each other.
That makes sense, but how do you differ between the different states of matter?
Well, there are two different processes, endothermic and exothermic phase changes. Endothermic phase changes absorb heat and exothermic release heat.
Are there different types of endothermic and exothermic phase changes?
Yes, actually there are. There are three endothermic phase changes: melting, which is going from solid to liquid.
Oh, so like an ice cube melting.
Yes, exactly. This is an example of melting because the heat energy near the ice gets absorbed back into the ice. Endothermic phase changes are vaporization, which is a liquid going to gas, and also sublimation, which is a solid going directly to a gas. The exothermic phase changes are condensation, which is gas going to a liquid, freezing, which is liquid to a solid, and finally deposition, which is a gas going straight to a solid.
Okay, I think we have a good understanding of phase changes now. One thing I was always confused about in my high school chemistry class was intermolecular forces. I know that London dispersion forces, dipole-dipole forces, and hydrogen bonding forces are all types of intermolecular forces, but I'm not sure what they all mean. Do you think you could fill us in?
Yes, of course. If the compound is nonpolar, then it automatically has London dispersion forces. For a compound to be nonpolar, it must have an equal distribution of electrons. If it does not have an equal distribution of electrons, the compound is considered polar. So if it's polar, the compound could either have dipole-dipole forces or hydrogen bonding forces.
How do we know if it has hydrogen bonding forces or dipole-dipole forces? If a compound has a hydrogen, is it automatically have hydrogen bonding forces?
Great question, but not quite. If a compound has a hydrogen and is pairing with fluorine, oxygen, and or nitrogen, it has hydrogen bonding forces. An easy way to remember this is an acronym I came up with, H-FUN.
Nice. And any other compounds are considered to be dipole-dipole forces?
Yes, you've got it now.
Do these forces have anything to do with the states of matter?
Of course they do. As exothermic phase changes occur, the energy decreases while the intermolecular forces increase. This is because, according to the kinetic molecular theory, the space between the particles is actually decreasing. For all endothermic phase changes, the intermolecular forces would decrease.
Sounds good to me. Unfortunately, that is about all the time we have tonight. Is there any last thing you would like to tell our viewers?
Yes, a major misconception with phase changes is people think that they are chemical, but the most important thing to remember is phase changes are physical. Thank you so much for having me.
No, thank you. And good night, everyone. Thank you for watching Channel 4 News. Catch you tomorrow night.